All right. Can you all see my PowerPoint slide? Welcome to week 14. Someone's coming in just when I get started. All right. And first, I'd like to wish you all a very happy Thanksgiving. I hope this will be a thankful week for you all. Hopefully, well, you don't really get a break in this class, but take a break on Thursday and spend time with family and friends and all that, you know. But I hope that you have a very thankful week. All right. All right. Getting into our schedule for tonight, we're going to go into section 15. And that's views. Topic 1 is creating views. Topic 2 is operations and views. Topic 3 is managing views. And then we just have the practice from section 15, but we're combining a couple sections again. So be aware of that. We're going to go into section 16, just 2 topics there. This is sequences and synonyms. Topic 1. Okay, hold on. All right, topic 1 is working with sequences, and topic 2 is indexes and synonyms. And then you have 2 topics or 2 areas of practice from section 16. And then you have the section 15-16 combined assignment. It's not too bad. And then 15-16 quiz. So that's what we're going to cover as far as the topics. And those are due on Sunday, as usual. And then what I'd like to do is just spend a few minutes opening up discussion or starting the discussion on the final project. I will tell you that basically you'll have everything you need to complete the final project without too much of an issue. It's a little bit of work, but we're going to talk about that briefly at the end of the lecture. Okay. All right. So let's get into this. I'm going to stop this. And stop sharing. And then I should just pull over the browser. Just a second. Right, make sure I got everyone present. Yeah, looks fine for now. All right. So in Canvas, we're going to begin our conversation about views. Just to preface this, think of views as kind of like temporary tables, or you treat them just the same way you treat tables. So just remember that. So let's get into our lecture material here. Topic 1, creating views. Our objectives, there's 3 uses. For views, from the standpoint of a database administrator, there's usually a database administrator or DBA that will probably use the views the most. Explain from a business perspective why it is important to be able to create and use logical subsets of data derived from 1 or more tables. It's very useful, especially with the top-end applications, etc. Let me stop the share for a minute and restart it. All right, I just want to make it a little bit easier on myself. So hold on a second. Let's do this. Okay, so back into. And can we all see that okay? And to our first topic, create a view with and without column aliases in the subquery using a single base table. Create a complex view that contains group functions to display values from two tables. Retrieve data from a view. All right, so let's get into it. Once again, views are they're still pretty important as far as databases, and because we have so many functions or applications that are hitting data, and this is usually where a view can be very handy. All right, so let's take a minute to look back at what we've learned. How easy would it be to explain what you know to someone who hasn't taken this class? You should pat yourself on the back. You've amassed a level of knowledge that basically, hopefully, this hasn't been just a checkbox of activities. You've learned a lot about SQL and relational database models, which is so important in our world as we continue to evolve. So now imagine yourself as a DBA of a business. It is possible. What do you do when a manager asks you to make it possible for him to be able to retrieve and input data using the company's database? Usually a DBA will say absolutely not. In the old days, it was just not impossible. Managers would send requests, etc. But in the modern day era of front-end applications, of course, you as the DBA will have to manage the access to the data. So the key here, don't make it too complicated. The manager says, I just want to be able to prepare reports, which is usually the case about all of our operations. They usually say that. So, should these employees have access to all the company's data? No. How will they execute commands that require join conditions? It is wise to allow data input from everyone, data entry and all that. So these are the questions that a DBA will need to know how to answer. And this is managing basically how the data is accessed and who can do what. Generally, things like updating records, etc., are not allowed. But in this section, you'll learn how to create views, and these are virtual representations of tables customized to meet a specific user requirement. And remember that specific user requirements. And it seems like you've run across many aspects of the relational database model where you can, based on a scenario, you can create specific reports, result tables, or views. Technically will make that easier, and that's what we're going to look into. So a view, like a table, is an object, a database object. However, remember, views are not real tables, meaning they're not real objects. They're basically created ad hoc mostly. So they're logical representation of existing tables or another view. So a view could be a view of a view. That can get a little convoluted, but generally a view is very specific. Views contain no data on their own. Remember that. They function as a window, which is why it's called a view, in which data from tables can be viewed. It's pun intended, or changed. And it was pretty pertinent in the beginning of establishing the whole idea of a view. Make sure that this is something that a user can see and can treat it just like a table or an object, but not impact per se the actual data. So the tables in which a view is based are called base tables. Remember that term is important. The view is a query stored as a select statement in the data dictionary. So you hear the syntax here, or this example: create view employees. That's the way they create. That's the name of the view. As, and then you have a select statement: select employee ID, first name, last name, email from employees, where employee IDs between 100 and 20. So this is going to be a view. So you probably would maybe name that a little bit more specific, but that view is going to be this simple table with these, 7 employees. And you can actually access that view like a table. See, it just select star from view employees, and you'll get this nice little simple table with ID, first name, last name. That is a view in a nutshell. And it can be very, very useful to provide access, a specific access by managers or other users. So you wonder, okay, well, that's interesting, but why use a view? Well, basically views restrict access to base tables because a view can display selective columns from the table. So the user does not have to see the entire table, the entire base table. Excuse me. Views can be used to reduce complexity of the executing queries based on more complicated select statements. So generally, you have a pretty complicated select statement to create the view, and then the user, whether they're running a SQL scenario or using a form or whatever, it's pretty straightforward to access the data in that view. So for example, the creative view can construct join statements that retrieve data from multiple tables. Generally, you don't want a regular user or someone that's not a DBA or database analyst or whatever doing things like joins and subqueries. The user of the view never sees the underlying code nor how to create it. So basically, they just see the view. The user through the view interacts with the database using simple queries, and it's usually a select. It's usually a select, very basic select statement. And as I said before, this is usually invoked or generated by some type of front-end application or form. So views can be used to retrieve data from several tables, providing data independence for users. So in a nutshell, to summarize this, I mean, it's essentially views are used to restrict access, control access, and so the users, even if they're don't necessarily understand SQL or whatever, basically they can run a very basic simple query and retrieve data or see or view the data. All right. So as I said in that example, the syntax is create, and you can use the additional or replace, force, no force, view. And you give the view a name, and then aliases. And you can also add constraints, as we looked at before, check option, constraint, or read only. All of those particular aspects that you can use in a table, you can also use in a view. All right, to explain some of these additional components, or replace recreates the view if it already exists. So create view or replace, create or replace. Force creates a view whether or not the base table exists. So force, generally the view is connected to a base table, but force will create it whether there's a base table or not. No force creates a view only if the base table exists, and that's the default. And usually, unless you're really dealing with some complex issue, you want to create the view base connected to a base table. Alias specifies a name for each expression selected by the view's query, and you'll see an example of that here in a few. Subquery is a complete select statement. You can use alias for the columns. In the select list, the subquery can contain complex select syntax. So the subquery is basically where the complexity comes in for the view. So just remember that, all right? With check option specifies the rows remain accessible to the view after insert or update operations. So you want to make sure if you have the with check options, essentially you're continuing that access to the records for some reason. And we all know what a constraint is the name assigned to the check option constraint. But if there's other constraints in the base table, so we're going to see all this later, with read only ensures that no DML operation can be performed on this view. So it's only read only. So you can run a select, but you can't run updates or inserts to the view. Any questions about those particular components of the view? All right. And here none. Let's move on. Once again, here is another example. Create or replace view Euro countries as, and then remember as keyword types into your subquery that actually creates the data for the view. Select country ID, region ID, country name, capital from that table, WF countries, where location is like Europe. So you're essentially creating a table with all the countries in Europe, and that can be useful. So if we ran a select star from, an order by country name, etc., and we would get a result that looks like this. Okay. All right, there's a guidelines for creating views. The subquery that defines a view can contain complex. So the subquery can be as complex as you want. That's the whole idea of creating a view. And I've seen views where the subquery is, multiple lines with multiple cascading joins and everything else. And that's the whole idea. The subquery that defines a view should not contain an order by, no order by. That's one of the guidelines. So the order by is only used when you specify when you're retrieving data from the view. Remember that. That's the only thing that you can't use in that subquery. You can use the or replace option to change the definitions of the view without having to drop it or regrant object privileges. So basically, you can use the or replace if you want to make some changes in the internal attributes of the view. So alias can be used for column names in the subquery. So once again, the subquery is pretty important. If you want to change the names of the columns, yeah, you can use aliases. All right. And there's some features with creating views. Two classification views are used, simple and complex. The table summarizes the features of each. So a simple view is one table, complex view is one or more. A simple view can contain functions, and we haven't talked about, but there's quite a few functions that we know about, but you don't want to put functions in a simple view, but obviously in a complex view. A simple view doesn't contain groups of data, whereas a complex view will. So a complex view is usually where you're landing. Can perform DML operations, insert, update, delete through a view, yes, but you have to be very careful with the complex views because you probably are protecting that data or protecting the validity of that data just to simplify the access or retrieval of such data. So usually you don't want to use the DML, the inserts, update, or delete. Generally in a view, you rarely see a delete DML ran. So remember that. All right, simple view. Basically, it's one base table. And here's an example. Create or replace view. The countries one. This one, just one table. Country ID, country name, capital. As we saw before, that is basically a simple view. Because it's a simple view, insert, update, delete, and merge operations affecting the base table could possibly be performed through the view. But I would suggest that you generally don't want to complete. Well, that's why you make it a simple view. If you're working on a simple view, make it a simple view. I mean, you can create a more complex view from that, but based on whatever your scenario is, if you're thinking about a simple view, keep it simple. So the simple view column names in the select statement can have aliases, as mentioned before. So if you just want to change, some of the column names, you use the as keyword. You see that you have the as keyword. Note the aliases can be listed after the create view statement or before the select subquery. So here the aliases are listed as you know, we selected columns. Here, they're listed before the subquery. Make sure you understand the difference between those. Both are the same and both do the same. This is a little cleaner, and you can get a little bit lost with all the as keywords in here. That's why this one was created. All right. So it is possible to create a view whether or not the base table exists. That's when you want to use the keyword force. As a DBA, this option can be useful during the development of the database. Probably not that useful afterwards. You know, you generally want to tie, as I say, and I'll stress this more and more, the view to an actual base table. And the force option will create a view despite it being invalid. Once again, primarily used when you're building the database. All right, hold on, someone else is coming in. Second, mark this individual present. All right. So the no force option is the default when creating a view. So, and all it says is that a view is associated with an actual table in the database. You're not forcing it for some reason. Complex views are views that can contain group functions and joins. And this is generally, in my experience as a DBA, all of my views were associated with complex views associated with multiple tables. So basically, and we've seen joins. So you see in this example, we're just using a join within our Euro countries. So we're using the WF countries and WF world regions, using region ID as our join attribute. And so that view is a little bit, it's only complicated because we have more than one table. Remember that. And when we select it from that table, then we get a nice view of that data connecting to those two tables. All right. In a complex view, you can also use group functions. So in here, we're running this view high population with aliases region ID and highest population. And we're selecting region ID and max population from these countries grouped by region ID. And so that's using the group function to bring in the highest population from the region. Remember, the reason why we're grouping by the region, there are several countries in that region. All right. All right, you can modify a view. The best way to modify a view is to create or replace. And basically you can make changes to the subquery and it will modify that view with the new changes as soon as you run that particular create or replace statement. Create or replace. All right, so that's kind of a quick and streamlined lesson on views, basically using views. What is a view? So our terminology: aliases, complex view, break view, force, no force, replace, simple view, subquery. Remember, the subquery is the query that essentially creates the view, and the view name, as you saw in the example, create or replace, and then you have your view name. All right. Hopefully the summary. Okay, so that's the first introduction to views. Now let's take a look at DML operations in views. And DML, remember, is not just select, but the update, insert, delete. So in this topic, our objectives are write and execute a query that performs DML operations of a simple view. Name the conditions that restrict your ability to modify view using DML operations, which is important. write and execute a query using the with check option clause. Explain the use of the with check option as it applies to integrity constraints and data validation. Apply the with read only option to view to restrict DML operations. I can tell you right now, most of the views that I created were all with read only. Just because I didn't want anyone to run DML on the view itself. DML commands. All right. I'll pause. Any questions or comments? Nope. All right, let's move ahead. All right, so as you learned in the last lesson, views simplify user access. And usually a DBA will use views a lot to contain to access to data contained in one or more tables in the database. However, views also allow users to make changes to the underlying tables. Yes, this. I mean, if you are a DBA, you have to be very careful on DML and views because you can make changes. So as a DBA, you're the person whose job is to maintain the integrity of the data. That's your number one responsibility, which is why you have constraints and all that. So if you create views and you're allowing DML and you're allowing updates and deletes, then that's creating more complexity for yourself. But in this lesson, we'll learn how to allow data access and at the same time ensure data security, which is very, very important in our current landscape. All right, so we know the DML operations insert, update, delete, and they can be performed on simple views. As I said, when I was a DBA, I did not really allow this on views. So these operations can be used to change the data in the underlying base tables, and that's the key. This is where you need to understand that if you're running a DML on a view, you're actually impacting the base table. And basically, you allow them to do this if you're going to create a view that's unrestricted. So, all right. So just in my experience, as I continue to state, generally I would create a view for a simple reason, and then sometimes it would simply be a one and done. But so, for example, views shown in the right was created for, or below, was created for the manager's department 50 from the employees database. The intent of this view is to allow managers of this department to see information about their employees. So, and you would think that, if you're the database administrator, well, if you're in a large company, there's no way you can keep up with all the requests. So you do give them access to views, and that's generally why you would do something like this. So remember, this is just a view, Department 50, a good naming convention. You have all the employees in Department 50, right? All right, so using the view as stated, it is possible to insert, update, and delete information. This may not be what the DBA intended. Once again, when I created views, it was definitely what I intended. So definitely not what I intended. But to control data access, two options can be added to the create view statement with check option and with read only. My views are always read only. The view is defined without the with check option here. That view. So using a view. So basically, it will check to make sure it's in alignment. That's essentially what the check option is. To make sure you're not changing the integrity of the data. So this is defined without the check option, and you can change like this department. So the with check option ensures that the DML operation performed on the view within the domain of the view, and basically it's going to check any attempt to change the department number for any row in the view fails because it violates the with check option. So it's a constraint. It'll attempt to change it within the, as it states here, the domain of the view, but not the base table. That's the whole idea. Something like, this department ID is probably your primary key. It probably has constraints and unique constraints on it in this particular table, so that the with check option will, disallow that. So the syntax is just your subquery at the end of your subquery with check option constraint on that view, department 50, and that's what we're naming that constraint. Okay. So now if we try to change the department, we'll get the warning or the error. There's a with check. Once again, just another constraint that you have to be cognizant of. With check option is great because it will disallow if someone's trying to do a DML. But as I said, read only essentially provides just a simple way for a user to view the data without running can't run any DML, insert, update, or delete when you have when you add the read with read only. And I would say about 90% of the views that I created were with read only. All right, let's talk about DML restrictions. Simple views and complex views differ in their ability to allow DML operations. And we just went over that. For simple views, DML operations can be performed through the view. For complex views, DML operations are not always allowed. And generally, if it's a complex view, I would certainly not allow any DML. And the thing is, you have to ask yourself, in a scenario, why use a view if it's a simple view anyway? Maybe you can, well, once again, it's controlling access to that particular table. So you do have to be careful about that. So that's why on complex views, yes, you really don't want anyone to be manipulating the base tables. And that's the key. As far as DML restrictions, you cannot remove a row from an underlying base table if the views contain any of the following: group functions, group by clause. So you have to be aware of that. A pseudo-column, row num, keyword. Any of these you can't, and you probably wouldn't want to in this scenario. This is another one of those common sense things. You cannot modify data through a view if the view contains, oh, we just said that. You cannot add data through a view if the view includes, oh, just continuing our list here, does not include, not null. All of these particular items create restrictions as far as views. So make sure you're aware of these 6 restrictions as far as DML. And you'll learn very quickly. Views are useful in certain scenarios. And if you're the DBA, if you're going to allow that type of access, then you're probably controlling the way the views are created, etc. Just remember that part of it. Okay, so this basically the important terminology in this particular section as far as controlling DML. You have the add-ons with check option and with read only. Very, very important. You'll see that in our examples. All right. Any questions or comments about that particular aspect of views? Okay, moving right along. Topic 3, managing views. Our objectives: create and none. Execute a SQL statement that removes a view. Always you have to remove them. Create and execute a query using an inline view. Very, very important because those are the lines of applications using accessing data. Create and execute a top-end analysis query. And that's pretty interesting. Or should be. We'll see. All right. Learning to create and replace views wouldn't be complete unless you also knew how to remove them. Views are created for a specific purpose. That's probably the biggest key here. And in most databases, you may see a lot of views, but they're stored as objects and they're always stored as a specific purpose. And it's just like little sub-programs. When a view is no longer needed or needs to be modified, The means exist to make the necessary changes. So if an employee has access to financial information, leaves the company, you probably don't want them to view to maintain their access, right? So we're going to learn how to basically delete a view, create an inline view, construct a select statement to produce a sorted list of data. Yeah, it's interesting. Top-in analysis. All right, deleting a view. Because a view contains no data of its own, removing it does not affect the data in the underlying tables. Please remember that. I mean, you can manipulate views until you're blue in the face and you're not changing any of the data. If the view is used to insert, update, or delete data, those changes in the table will remain. So once again, you would have to be very careful on what's happening, who's doing what. But deleting the view is very simple. You basically remove it as an object in your database, in the data. So remember, views are stored as select statements in data dictionary only. Well, yeah, only the creator. So the syntax is simply drop view and the view name. Just that simple. All right. No complexity there, right? All right, inline views are also referred to as subqueries in the from clause, excuse me. You insert a subquery in the from clause just as if the subquery was a table name. So you're going to see that, and it's just making it in line with the query itself. Inline views are commonly used to simplify complex queries by removing joins, operations, and condensing several queries into one. And you can use this in many ways, but let's take a look at this. And you've seen this before with the subquery section. So you can do it inline. So basically, as shown in the example, well, the from clause contains, and we've seen this before. Remember, it has to be enclosed in parentheses. Select statement that retrieves data, much like any select statement. And it is basically like any select statement. So we're aliasing or that whole select statement as alias D. And the data returned by the subquery is given an alias, which is then used in conjunction with the main query to return select columns from both query sources. So this can be confusing. So this whole select is given the alias D, and then that's used in your where clause. So make sure you take a look at this and you can walk through this and understand what's occurring. Like E last name, which is our employees table, salary, department ID, max salary from employees, right? And then select, which is treated as another column, right? Department ID, max salary from employees, grouped by department ID. And that whole select statement is alias as D. And so you're essentially eliminating a join here. It's kind of the same thing. And we call that an inline view. So make sure you understand that particular query. All right. It should run that. Any questions about that query? Any questions about why you would use that versus a join? It essentially does the same thing. We're just wanting to use this group function essentially to join the results. I wonder if we ran that. Yeah, let's run that. See what, take a pause and see what the results are for that. Okay. Open. Okay. We're going to use. Let me get the query going and then make sure payments again. 1 second. All right. Ooh. Oops. All right, I'm trying to. Let me stop sharing for a second here. And bring on the second developer here. Richard in. And then I'm going to share an screen. Give you all a chance to wake up a little bit, right? All right. Share. All right. So we're gonna see if I can put this without making too much of a mess. All right. Last name. Salary. Need apartment ID, right? Salary from employees. That's going to use this E. And we're going to add our little subquery here. Select an ID. Salary. And this is where we're using an alias. It's all right. From employees. And that whole thing is going to be, we're going to have a group by first, group by department ID, right? Group by department ID. And that whole inline view, so to speak, is our, so where department ID is department, where the ID is equal to D, right? And the salary is equal to max salary. Right? Is equal to D max. Right? And we can run this. There you go. Well, last name there. So it's just another way. You could probably have done that with a simpler query, but that gives you an idea what inline queries are all about. Inline views. You may want to, yeah, run something like that, but just shows you that you have the capabilities of creating an inline, what we call inline views. So, yeah. All right, a little bit waste of time, but all right, top-in analysis is a SQL operation used to rank results. The use of top-in analysis is useful when you want to retrieve the top 5 records or top number of records or results set returned by a query. So select row num as longest employed, last name, hire date from employees, where row num is less than 5, order by hire date. So basically, we're getting the top 5 employees that have or the 5 employees that have been there the longest. So, all right, and that's called top-in analysis. And it's just a way of ordering something with a pretty straightforward, simple query. All right. So the top-in analysis uses an inline view or a subquery return result. You can use row num in your query to assign a roll number, the result set, and the main query then use row number to order the data and return the top 5. So it's just like row num, there's longest employee, from, select last name, hire date, order by hire date. So once again, it's just a kind of a shortcut and simple way to order. You know, they came up with this catchy name, top-in analysis. Order the same scenario where you're wanting to return a list of the employees that have been there longest. So it's using inline view, that's like last name, hire date from employees, and then order by hire date, as you see here. That's our inline, just to make sure they are in order. And this is just the roll number here. All right. That's what that roll num function returns. And so to break that down, this is how you would run a top-in analysis for that particular reason. So 5 or less than, pretty straightforward. All right. So for this topic, we learn how to drop a view or delete a view. We learn inline views, which are just basically subqueries in the from clause, remember that. And then top-in analysis just uses inline views, and a roll number is just a function that returns the number of rows. Not too bad. All right. And you will see examples of that. So that's section 15. It's basically views and some of the usages of views. If you want to run some of these queries, I think I have that query here. All the ones that were illustrated in the lecture are in this download for chapter 15 SQL. So please use that. Okay. And then we have our practice, and we have for the 3 topics: creating views, the objectives and the vocabulary, and to try and solve it as usual. We have 3 sections of that, or 3 areas of that in the section. And then the solutions, right? We always give you the solutions, so compare your answers. And then that's it. So basically nothing to complete as far as assignments in section 15, but you will loop back to that in section 16. And in section 16, we have 2 topics. We're going to learn about sequences and synonyms, another aspect or component of, and somewhat useful, some depending upon what you want to do with your data. But, all right, the first topic is working with sequences. List at least 3 useful characteristics of a sequence. Write and execute a SQL statement that creates a sequence, another object. Query the data dictionary using user sequences to confirm the sequence definition. Apply the rules for using makes val to generate sequential unique numbers in a table. List the advantages and disadvantages of caching sequence values. In 3 ways, 3 reasons why gaps can occur in sequences. Yeah, a lot of fun, which is, I stayed away from sequences. I don't know. In my day, well, I don't think I was lazy or anything. I just didn't find a use for them. But anyway, let's take a look. All right. So can you imagine how tedious it would be to have to enter the names of 30,000 people who entered the London Marathon into a database, while making sure that no one was given the same identification number? That would be, pretty tedious, right? I mean, you have to handwrite 30,000 numbers. So what if you went to lunch and when you return, someone else had entered some of the runner's applications? Uh-oh. Now what do? How would you know where to start? Yeah, so this is the whole idea of sequences. Fortunately, SQL has a process for automatically generating unique numbers that eliminates the worry about details for duplicate numbers. And this is what's called a sequence. And it's an object. You already know how to create 2 kinds of database objects, tables and views. The third database object is a sequence. A sequence is a shareable object used to automatically generate unique numbers. And because it's shareable, multiple users can access it, which is a problem. Typically, sequences are used to create primary key values, like IDs, just to make sure that they're unique. That's the whole always. So as you recall, primary keys must be unique, and a sequence can be used to generate an increment or decrement by an internal, whatever routine. This object is a time saver for you because it reduces the amount of code. All right, so how do you create a sequence? So to create a sequence, yes, it's an object, so create sequence, and then the name. And then you list where it's the increment by value, the start with value. You can include the max value or non-max value, which goes on forever, the min value or non-min value, where if it's a decrement, the cycle or no cycle, cache or no cache. So there's a lot of controlling factors that you can do with this sequence. Generally, I would say, once again, you probably want to understand what you want, what you're meaning to accomplish, and go from there. So as I said, sequence of name is sequence, increment by specifies an interval between the sequence numbers, where n is an integer. Start with specifies the first sequence number. Max value specifies the maximum value the sequence can generate. Non-max, basically, you're giving a non-max, but you can go 10 to the 27 for ascending and -1 for descending. And specify the minimum value. Non-minimum values can basically go the opposite way of the non-max value. Cycle specifies whether the sequence continues to generate values after reaching its max or minimum value. No cycle is the default, so it doesn't cycle, it doesn't start again. And then cache and no cache specifies how many values the server pre-allocates and keeps in memory. And this used to be very important, caching and all that, with the very large amounts of memory now compared to 10 and 20 and 30 years ago. Your system usually won't crash if you generate a very large sequence. Even your laptops have more memory than our large capacity computers of 40 years ago. So, all right, so creating a sequence. So if we're creating a sequence for the London Marathon that we spoke of earlier, we're going to begin it with number 1. So create sequence runner ID, that's the name. increment by one, start with one, max value 50,000, no cache, no cycle. All right, pretty straightforward. So it's going to create a, so you're like, okay. So it is tradition that the best runner in an elite group wears number one. That's true. For other situations such as department ID, employee ID, the starting number may be assigned differently. So you may, like in our database, I think our well, our departments are different, but our employee IDs, well, maybe they're 1 or 101. But anyway, because there are at least 30,000 runners, the sequence's maximum value was set well above. Yeah, that's why we did that. The no cache option prevents sequences, values in the sequence from being cached in memory. Yeah, once again, that's generally the default. So, and no cycle says it's not going to cycle. It's going to stop at 50,000. All right, you can confirm a sequence after it's generated. You just query the data dictionary. You can query it for user objects and find your user sequences, and then you can query the sequences. The sequence name, minimum value, maximum, all of that, right from that table in the data dictionary. If no cache is specified, the last number in the column, and the query displays the next available sequence number. So yeah, if cache is specified, the last number column displays the next available number in the sequence, which has not been cached into memory. So basically, it tells you, and generally, you know, if you're caching in memory, you can get an idea of how large the sequence is. That's the whole idea. All right, you can use the next val or current val, which is next val, current val pseudocolumns, is used to extract successive sequence numbers from a specified sequence. You must qualify next val with the sequence name. When you reference sequence next val, a new sequence number is generated, and the current sequence number is placed in current val. Yeah, does that make sense? So here's an example. Insert into departments, department ID, department name, location ID, values or department. You're using the sequence. We created this before, and we're going to say next val. I'm going to call the department support, and the location ID is going to be 2500. So it's, this way you don't really need to know what the department ID is. You're just using that sequence, which was defined before, to create the next value of the department ID. That's very useful if you, yeah, if you're not keeping track of some, or you have a very large company. So suppose now you want to hire employees to staff the new department. The insert statement to be executed for all new employees can include the following code: insert into employees, employee ID, department ID, etc. And now you want to use another sequence, this employee sequence, which was built for the employee's ID, department ID sequence, and current val. So basically, the current value now is the value of that department sequence that was stored when we ran that query before. Just remember that. Note the preceding example assumes that the sequence called, yeah, has already been created. The same with the department sequence. These sequences have been created, so we can use that in our insert data just to make sure we're getting unique values, etc. Does that make sense to everyone? It is pretty important to make sure you understand how you can use these sequences as long as they've been built and are objects in your database. This is where they're the most useful. All right. So the current val's pseudo column, an example before or an example that's coming up, is used to refer to a sequence number that the current user has just generated. The next val must be used to generate a sequence number in the current user session before the current val can. So basically, you generate a current value that's, you know, that's stored as a value. Then you can use the next value after that. So you must qualify the current value with the sequence name. So that's that's what we're doing here. That way we know that we're having the correct value for this employee. Because it is the department ID, right, that we just created. So remember, this next val is the next employee that we're adding to the department. This current value is the value of the department that we just created way back here. Right? All right. So when you run these, you'll see how that works. It's best to run them. This is what the next value is. This is what the current value is. Just keep those pseudo columns, clear in your mind, then it's less confusing. All right, so after you create the sequence, it generates sequential numbers for use in your tables. Reference the sequence values by using the next val and current. And these are pseudo columns, so you can use these as like functions as long as you have the sequence dot next val or sequence dot current val. And if you're unsure, I definitely would look at that sequence and its current status in the data dictionary. So that's something that you probably want to keep up with. So you can use the next val, current val in the following contexts. Select list of select statements that is not a part of the subquery. Select list of a subquery in an insert statement, the values clause in an insert statement, set clause of an update statement. So basically those particular values that you are aware that you want to appear in these particular components of your queries, you can use the next val, the current val. Remember, it's the sequence dot next val current val. You cannot use them and these are, basic rules in the current context. The select list of a view, no sequence. The select statement with the distinct keyword, nope. The select statement with group by having or order by, no next val or current val. That should make sense to you. A subquery and a select delete or update statement, nope. The default expression in a create table or alter table. Yeah, these things, no, do not use next val, current val. You will create problems for yourself. All right, so to continue our little example about our runners in the marathon, we're creating this table called runners. This is our table with our runner ID being our primary key, first name and last name, pretty straightforward. So that's pretty easy. You know how to do that. And then we're going to follow that up with creating a sequence, call it runner ID, increment by one, start by one. And we saw this before. And now we can actually input our runners and not have to worry about. And usually, I'm pretty certain now, I haven't seen the back end of these forms that users fill out. Usually they'll have these running in the back end when you go into register for one of the races. It's using a next val and then it's taking your first name and last name to create your runner ID, and then you print it out in sequence and you're all good to go to run the race. And remember, to confirm the sequence, make sure you can always select the table. Let's see, we got runner ID 1 and 2 and Joanne Everly and Adam Curtis, which we inserted here. And to view the current value of the runner sequence, just in case you went to the bathroom or whatever, you can use the dual table or exponential table. Select runner ID sequence current value from dual, and it'll give you the current value of the sequence as a. So generally, if you're running that query to update the runner's IDs, it shouldn't be a problem, but if you take a break, this is how you can keep up with the sequence. Cache sequences in memory provide faster access to sequence values. Once again, I will tell you that caching, as far as a resource in the current database structure and memory allocation is not such a big deal anymore. This does say that 20 is the default number of sequence numbers that are cached. It's actually much higher than that. In Oracle, what level of Oracle we are on now, but you don't have to really worry about caching and memory in our database structures now, even in our basic databases. All right, so all those sequence generators issue sequential numbers without gaps. This action occurs independently of a database commit or rollback. So gaps or non-SQL numbers can be generated by, doing a roll or rollback. Obviously, you're going to create a gap. And if the system crashes, well, you can't prevent that, but and I've had that happen to me before. You simply have to use some critical thinking or fast thinking to at least close the gap or make sure you're not duplicating numbers and things like that. So these are the particular reason why we would get a non-sequential scenario. So once again, you can view the values of a sequence by querying the data dictionary. This simple query, select sequence name, minimum value, maximum value, number, last number as makes number. So you basically see that we added 2 runners, so our next number is 3. You should always check something like this if you're not sure. That is the general rule. So modifying a sequence, you can use the alter command, alter sequence. Let's say we want to change the maximum value to 999,000. So basically you would create your query that looks like this. Alter sequence, the name of the current sequence, and then what you're going to change. All right. The one thing you cannot do, you can't alter a sequence and make like a maximum value less. You will get an error. You can make it more or the same. Why would you want to make it less? That's not smart. You would have to remove the sequence. So there are a few guidelines. You must be the owner. Yes, only future sequence numbers are affected by the alter sequence. The start with option cannot be changed using alter sequence. The sequence must be drawn first and then recreated to restart the sequence. Removing the sequence is pretty straightforward. You just drop the sequence and drop sequence and then the sequence name. You must be the owner, etc. Once removed, the sequence no longer be referenced. So you can't, basically, it's gone. All right, so that's the down and dirty on sequences. Some of our terminology: cache, no cache, create, current value, cycle, no cycle, increment by, max value, min value, next value, no max value, no min value, sequences, and start with. All right. Our last topic, indexes and synonyms. Our objective is to find an index, and we kind of know what an index is, but we're going to get into the definition here, and it's used in a schema object, which is a database object. Name the conditions that cause an index to be created automatically, and very useful. Create and execute. And indexes are a little bit different than sequences, and you'll see why. Create and execute a create index and drop index statement. And yes, indexes are what, create the order, just like the indexes in the library. Create and execute a function-based index, create private and public synonyms. Kind of a lead. Synonyms are, you'll see here. Kind of tail end of what we consider indexes. All right. All right, so can you imagine one of our explanations again, going to a bookstore or library and finding all the books stacked on shelves, row after row, in no real order. Hence the Dewey Decimal System. Anyway, the only way to locate what you're looking for would be to examine every book in every row. That's really not smart. Not very efficient. Yeah, we all agree with that. So you may be surprised to know that retrieval data from a database is exactly like the row of books. So for every query, a full table scan happens, and this is true. Unfortunately, there's a way to make finding data in a database more efficient. And if you think about our data currently with the the large data models with the millions and even billions of rows. Oracle uses index to, well, all databases use index to speed up the retrieval of rows. So we're going to learn how to create an index as well as how to delete. Also, we're going to learn how to create user-friendly names for database objects, much like internet web addresses, and eliminate having to know the internet protocol or the IP address. Synonyms provide a way to give an object a simpler name. So it does sound like aliases, doesn't it? And it kind of is. Synonyms, yeah. All right, so indexes, what are they? Basically, it's a way to order your records. It acts like a pointer. Indexes can be created explicitly or automatically. So you do not have if you do not have an index on the column you're selecting, then a full table. So basically, you're building efficiencies. So an index provides direct and fast access to rows in a table or records in a table. Its purpose is to reduce all the input output. And it does, the way the database is structured it is the one thing, especially now with the large database models, that can be used to make the database more efficient. An index is used and maintained automatically. Most servers and systems will do that. You don't really need to access, or there's no activity needed by you as a direct user. A row ID is a base 64 string representing the row. Indexes use row ID because they're fast. So it basically is a way to find a simple a record in your table. Indexes are logically and physically independent of the table they index. Remember that. That'll be a database test question. This means that they can be created or dropped at any time without affecting the data or the table structure itself, or even other indexes. So like our country, or I don't have countries table. Basically, and the thing of it is, you think of indexes as being basically the ordering system in your table that you may not, you usually don't recognize it, but like country ID is not your index, remember that. That's just your ID. So that produces a level of confusion, but remember indexes are created usually by you as a DBA when you're creating the tables. And you'll see how that occurs. So when you drop a table, corresponding indexes are dropped. And there are different types of indexes, or two types. There's the unique index, and this is automatically created by the server. And basically in a table that has a primary key or unique key constraint, the name of the index is the name given to the constraint. So primary key could be your index, and usually you can make that correlation. So although you can manually create a unique index, it is recommended that you create a unique constraint in the table, which implicitly creates a unique index. So, and when you list that particular column as a primary key, you're indexing your table. And then there's non-unique indexes. So this is an index that the user can create to speed up access to a row. So yes, you can create a explicit index. For example, to optimize joins, you can create an index on the foreign key column, which speeds up basically when you're joining table, you're actually indexing the join scenario, which speeds up the whole search process, etc., which is the whole purpose. Excuse me. So creating an index, okay. I'm just reading the chat. All right. So to create an index, the syntax is create index, and then the index name on table, the table name, and then the column. To create an index in your schema, you must, create privileges. To create an index in any schema, you need that privilege, and you all have that privilege. Null values are not included in an index, remember that. So for example, to improve the speed of query access to the region ID of WF countries, we can create an index called it WF country region ID index, IDX, just a naming convention on WF countries in that column. So now you're going to index that column, and now you have a way to search that column or search that table with that specific column as an index. It just speeds up, makes it more efficient. That's generally what we want to use an index. So when do you want to create an index? So an index could be created only if the column contains a wide range of values. A column contains a large number of null values. One or more of the columns are frequently used together in a where clause or a join condition. The table is large and most queries are expected to retrieve less than 2 to 4% of the rows. So this is when you want to create an index. I will tell you that generally the DBA will, well, 100% of your table should have a primary key, which is usually your unique value that creates the index of your table. But if you have joins and views and other complexities, you may want to think about creating another index on one of the columns. That's the key here. But there's a scenario where you don't want to create an index. When deciding whether or not to create an index, more is not always better. Definitely do not create a lot of indexes on your table. That's almost like overthinking. So each DML operation that is performed on a table with indexes means that indexes must be updated. And it's not a big deal to update indexes, but be very careful. The more indexes you have associated with a table, the more effort it takes to update all the indexes after the DML. So that's the key. And as I said before, usually your index is probably your primary key. They're not the same thing, but that's how you're indexing your table. Just remember that. All right, so it's usually not worth creating an index if the table is small. The columns are not often used as a condition in a query. Most queries are expected to retrieve more than 2 to 4% of the, so basically more of the table. The table is updated frequently. The index columns are referenced as a part of an expression, so you don't necessarily want to create indexes. I will tell you that for the most part, a relational database, it consists of, whether it has many records, but tables, we'll call them relatively small tables as far as the number of columns to create that referential integrity that we talked about a long time ago. So generally, indexing at this point, you have to be very careful. In the old days where it's just 1 or 2 very large tables with hundreds and hundreds of columns, obviously that before the whole idea of a relational database model, then that obviously indexing was very important. So, all right, you can create a composite index, and it's called a concatenated index, also called a concatenated index. And basically it has multiple columns in the table. And that can be useful if you want to use something like, names, first name, last name as an index, as opposed to one name. So you want to create a composite index, you just create the index, give it a name, and then you add more than one column. That is allowed. All right, null values are not included in the composite index, yes. So remember that null values always have to be handled. Job joins, you can create an index on a foreign key. You generally do that anyway, foreign key, primary key. The optimizer does not use an index if the where clause contains the is null expression. So no. And once again, nulls create a different scenario for you. You have to be very careful. As far as confirming the indexes, there is a user indexes table in a data dictionary. So yes, you can confirm the indexes there. Just run a select query. You can do a select star to see what the columns are and then add your specific columns needed. So in this example, we're using distinct, although, well, you get the distinct name, index name, it shouldn't be any overlap, but I see index name, I see column name, I see column position, ID uniqueness from user. indexes. And we're doing an explicit join here, but this is a good way to see all the indexes on a particular table. Yeah, just to confirm that it does have indexes. And you see here, it's primarily primary key, other types of indexes here, unique, non-unique. Yeah. Well, that's a way to confirm your index. There are function-based indexes. A function-based index stores the index value and uses the index based on a select statement to retrieve the data. It's just like a function. So the function-based index is an index based on expressions. An index expression is built from table columns, constants, SQL functions, and user-defined functions. Function-based indexes are useful when you don't know in what case the data was stored in the database. For example, you can create a function-based index that can be used with a select statement using the upper function, remember that's all uppercase, in the where clause. So the index will be used in this search. So create index. And basically, we're using an index, with the function upper. So here, select star for employees where upper last name is equal to king. And this is a very simple usage of that, but now we can use that as an index. So function-based indexes define what the upper and your column name and lower allow case-sensitive searches. So that's basically it'll search for anything and make sure it's upper or lower. You don't know how the employee. So if you don't know how they were entered, then you can use that type of index to make sure you find the data that you're searching for. So when a query is modified using expression and where clause index won't use it unless you create a function. So in this whole upper and lower case, it's primarily, just to reiterate, primarily used for searching on keywords where you don't know the case in that scenario. And here's an example. So you're saying that we don't really care about the case of this entry. We're looking for this particular individual with these last names. So we're looking for King. So this is another way to search. Now, do you need to create an index like this and not use the function? That's 6.5 dozen of the other in that scenario. To offer an explanation of this, because it goes into this a lot, you're looking at efficiencies and will it take longer to just use the upper function? Possibly not in our scenarios now. At one point it did, which is why we wanted to create an index. And this is where you have to be very careful. Is a function index better here? Possibly. So just think of it that way. So in these examples, we use the upper and lower function just for searching as far as case. There's a valid Oracle built-in function, for example, to char that can be used. I mean, there's so many different ways to create efficiencies here without creating more indexes, and that's the key here. Just remember that. All right, so another example of function-based index is shown where we're looking at something like a date as query results in a full table scan because we're looking for a date range. So even if the higher date column is indexed, the index is not used because of the to char here. So if we wanted to create an index of to char, so you're eliminating that full table scan, so it will find specifically, these particular individuals that have a higher date, 1987. Will that make a big difference? Possibly. I'll just say it that way. So indexes, remember, indexes are useful, but don't over-index. That's the key here. So removing an index, you can't modify it. You have to drop it and recreate it. That's really the only way to modify an index. To drop an index, you use the syntax drop drop index, and then the name. If you drop a table index and constraints are automatically dropped, but views and sequences remain. That's one thing about indexing. All right, let's get into the synonyms. Synonyms, as the word allocate, is a word or expression that is an acceptable substitution of another word. That's what the definition of a synonym is. Synonyms are useful to simplify access to objects by creating basically other useful user-friendly names. Well, I think for the most part, database administrators recognize that we read things a certain way. So generally our table names are pretty useful, or even column names. There was a time where that was not the case. The naming convention was something like what we see here, because it was required by the DBAs, because the DBAs had their own language. So no one really knew what the tables, what the schemas, what the columns represented. So that's what we're going into synonyms here. So creating a synonym eliminates some of the confusion as far as it's not such a big thing now, because we're all open to very English user reading friendly. But this method can be especially useful for lengthy objects such as views. And generally, if you want, well, as a database administrator, I was, how long ago was this now? Yeah, it's about 20 years now. But anyway, generally the DBAs will try to make the objects, even the long objects like views and etc. Even there, try to make it reader friendly. But we do have this thing called a synonym. And a synonym is pretty easy, so you can create, and it's a public, which means everyone will see this, create synonym, and then your synonym, and then your object. The public creates a synonym accessible by everyone. Synonym is the name, and object is the type of object. You can't see that, just create synonym. For example, we call it Amy imps or Amy copy employees. All right, the guidelines, the object cannot be contained in a package, and we haven't talked about packages, but packages are kind of a complex collection of objects. A private synonym must be distinct from all the other objects owned by the same user. So private is usually private to that user. But the public synonym, you can use a synonym for any object in your database, in your schema. And to remove a synonym, it's just drop. And if it's public, that's optional. The synonym, and then the name of the synonym. So, all right. You can confirm a synonym. It is an object in our data dictionary or a table, and synonym name, table owner, etc. All right, that was a lot of information. Remember, synonyms, if you really think you need to use a synonym, you can create one. But all right, as far as the terminology, composite index, confirming index, create public synonym, drop index. These are never really in a good order, are they? Function-based index, non-unique index, synonym, unique index. All right, so there you go. Sections 15 and 16. Once again, please go through the demo or the queries to get a deeper understanding of some of these particular aspects of SQL. It's very useful. I took out the additional resource because it's not really needed. I don't think you see that anyway. And then you have your two areas of topics. One is working with sequences, vocabulary, try and solve it. And the second one is indexes and synonyms, and including the solutions. And then our assignments for this week. We have the 15-16 assignment, not too bad. think the reason why I combine these is pretty short. 7 components, basically like to try and solve it. Should not be too bad there. 7 questions. And then your quiz, 15-16 quiz. It's a 25-point quiz. And that's due on December 1st. Any questions or comments? We've been gone a long time. All right. So what I'd like to do now is briefly open up the discussion about the final project. It is essentially a couple weeks away, but I want to start the conversation now. If you look past section 19, you have this final project, which is due the 13th. I know that's it's 3 weeks away now, or yes. And basically you're going to build within your database schema, you're going to build an additional, think of it as another schema, but you're building this, you're not creating a new database, that's not necessary. You can build these tables and all the connections within your current your Oracle Access. So it's a 40-point assignment. It's due on the last day, which is Friday the 13th. You're going to be applying the SQL concepts to create a function. It says functional database. As I said, please, and I'll remind you of this, you don't necessarily, unless you really want to be an overachiever, you don't necessarily need to create an actual schema. You can in Oracle, but we haven't gone to that level. But you got to create tables, going to add constraints, going to create views, create sequences, adding data to the tables, creating indexes. I mean, none of this is outside of the scope of what you've learned. But I'm going to provide you with tons of information. You get an ERD, entity relationship diagram, of your new structure. There's an overview in here, which I'll cover next week. And then there's a table description in here. Everything that you need as far as resources. But even more than that, I mean, I basically provide you, here's the overview, with a start of the queries. You can just walk through this and begin to create your tables. So that's one for your project. And you have to do this in developer or your current chosen platform. And then I give you also basically a rundown of all of the aspects in the second document that you should run and create screenshots for the final project. So basically you're taking this information that's provided to you and creating this movie rentals association. And as hopefully I'm not confusing you too much. You can create a new schema, but it's not necessary. I'm okay if you create these tables within our little database that we currently have, the ORCL. Because that is essentially well, we're not really going to go into that level, but all I'm concerned about is you creating those tables, creating all the constraints, creating the sequences, all of that, and adding the data. Does that make sense to everyone? Yes. And that's what the final project is going to be. It's just putting this all together. And what I'm going to probably ask, I usually ask the students, along with the data, there is a customer's part of the data. I do want you to add your information to that, along with the data that's there. So your individual information. So that's the project. And that's what I'm looking for as far as a submission for the final project. All right. And you have a ton of resources. There's really no reason to panic about that. well, then the final exam is something else, and I will cover that, the week after, well, next week as well, because the final will open up that Monday, the 9th of December. I mean, I'm not gonna cover that in this lecture. I just wanted to make sure you all understood the aspects of the final project. It's really just putting things together more than, trying to recreate the wheel. All right? Okay. So this has been quite an adventure. We only have technically 2 more lectures left. Our final day of class is the 13th, or everything is due the 13th. Our final lecture is the 9th, which is just 2 weeks, well, 3 weeks. So thank you all. I will see you all next week. Remember, you do have an assignment and you have items to complete this week. But once again, I hope you all enjoy your Thanksgiving. And no, don't do any work on Thursday. So you can wait until Friday. Okay. All right. Everyone take care.
All right. See ya.
Thank you.
Have a good Thanksgiving.
You
Happy
too.
Thanksgiving to you, Professor.
Thank you.
See ya.